Last time, we showed why we need a ring oscillator-based PO according to a few SerDes applications or usages. But that's not complete yet, and thanks to Europe's reminder for the additional image of the ring oscillator, which show you why we would like a multiphase VCO in ADC or DAC blocks for SerDes. First, let's look at the SerDes RXI for the clock data recovery CDR. As you may know, in the PO-based CDR, we have the first popular linear phase detector, which may only need a differential phase clocking without the need for multiphase VCO. How about the second and the most popular PAM4 PO-based CDR? Correct. There's no need for multiphase VCO for the 4A PAM4 CDR as well. But to have the best PPA in a high-speed SerDes, a half-rate or a quarter-rate clocking may be preferable. Should we need a multiphase VCO for non-full-rate PAM4 CDR? Yes, we may need a multiphase VCO generating at least 4 phases for PAM4 half-rate PO-based CDR. For example, the in phase at its differential could be for the data sample, while the quarter phase at its differential could be for the edge sample because of the 2x oversampling requirements. Similarly, you may need a more multiphase clocking if you may have a higher oversampling based CDR or another quarter-rate based CDR. In addition to the non-full rate or the oversampling PO-based CDR, what kind of other CDR would need a multiphase VCO? Think about a 5-phase resolution tracking images for 5 seconds. Bingo! Phase interpolator, PI-based CDR. In order to interpret the 5 phase for the phase of the data or edge sampling clock, a curved but precise multiphase is a must, and a multiphase VCO from a ring-based oscillator should be easier than any LC-based VCO. Please remember, the transmitter and receiver in a SerDes may have a frequency offset, and the PI's interpreted phase must rotate at a rate equal to the offset with a good phase precision. In addition to the source asynchronous SerDes system, what else do we need? The PI or multiphase VCO? Right. Even in a source synchronous link of a synchronous clocking system, the phase adjustment is still a must, even though the frequency offset between the TX and RX is 0. As you can see, the phase interpolation, phase acceleration, or phase rotation should source from a multiphase VCO again at the RXI to get the best sampling performance in a very low BL rate. In addition to the RXI, do we need a multiphase VCO on the TXI? Think about a low-cost image at a low speed for 5 seconds. Correct. If the RX has a low-cost requirement under a low-speed link system, we can apply the skew calibration at the TXI to equalize the phase between different lengths from the inherent skew because of the PCB or package trace routing mismatch. Since it's a low speed link, the on-chip phase skew could be little, and there's no need for an on-chip phase calibration, either at the TX or the RX side. But again, we might still need a multiphase VCO at the TX or RX side to help reduce costs in the PCB and package design under several versions. Before this discussion, we only focus on the NRZ SerDes system. Therefore, the half rate is more common, and we might only need the differential clocking instead of the multiphase VCO in the serialization or multiplexing. Then you should think about another high speed and high loss image for 5 seconds. Bingo! Due to the high speed and high loss, we must apply the PAM4 signaling to reduce the loss at the next rate. But the data rate at the 112 gigabit per second over 224 gigabit per second is still too high to apply a half rate. Therefore, the multiplexing is quite often to apply the quarter rate clocking over lower at the TX side, and a 4-phase or more phases clocking is needed to serializing the final output data up to the 4 rate, which is also a digital to analog conversion DAC functionality at the TX side. Similarly, the RX deceleration or the multiplexing should need the same 4-phase or more phases at the quarter rate clocking. How about the RX front end? Correct. The RX front end requires analog to digital conversion ADC functionality, and similarly, the full or half rate clocking is too fast for an ADC sampling due to the power and performance limitation. Therefore, in the PAM4 ADC based RX, people apply the time interleaved ADC at a much lower clock rate, but may require lots of multi-phase clocking to sample the input data. Of course, the much fine or more phases may still require the phase interpolation PI block, but the input of the PI may need more, such as A phase, to interpret or generate the fine phase spacing precisely. In addition to the PI-based ADC in a SerDes, do you need a multiphase VCO in the popular Delta Sigma ADC usage? Think about the time-assisted ADC images for 5 seconds. Great. Compared to the traditional voltage domain quantizer in an ADC, people start to explore a time domain quantizer, which has a less mismatch and metastability. In addition, most building blocks are digital, and there is no analog reference voltage needed. People apply the analog input to the VCO's control voltage, and we could tell the input level based on the count number of the VCO cycles in a defined time period TP. But the quantization step size could be too big to get a high resolution with a single phase from the VCO output. Therefore, a multi-phase like the time interleaved concept can reduce the quantization time step size by counting both the positive and negative edge from the multi-phase VCO cycles. There are lots of interesting design insights into the multi-phase VCO-based ADC. However, we don't have time to discuss it now, and we could focus on it later if there's more interest in your feedback. Here are a few summarized images of why you might need a multi-phase VCO for an NRZ or PAM4 ADC or DAC inside the SerDes. The first obvious one would be the 2x oversampling in a non-flow rate clocking, or any greater than 4x oversampling clock data recovery CDR at the RXI. In addition to the PO-based CDR, another popular phase interpreter, PI-based CDR, may need a multiphase VCO as well. Therefore, lots of phase selection, interpolation, rotation will be greatly applied to a source synchronous link of a synchronous clocking system for either a TX or RX for the phase skew calibration in package, PCB, or the on-die sampling phase optimization. For much higher data rate in a PAM4 SerDes, a quarter rate clocking starts to push the multiphase requirements at the TX situation and RX situation. In addition, the PAM4's RX front end may require the time interleave ADC to provide the best link performance, and the multiphase clocking is a must. Finally, we show another emerging VCO-based ADC will need multiphase VCO for sure to reduce the quantization step size or error nicely. I hope you can appreciate the multiphase VCO from the most covered usage or needs described above. Thanks for watching. Before you go, if you are benefiting from those circuit images, I would love to hear your feedback and please share your comments down below. Lastly, please share the video link with the people who may be benefiting from it.